Welcome to the deep dive. If you've spent any real time in software engineering, you definitely know this feeling. You're staring at a problem and you just get this sense of déjà vu.
Oh, absolutely. That feeling of, I know I've solved this before, but I can't quite remember how.
Exactly. And you end up solving it from scratch.
Yeah.
Again, it's completely exhausting.
It really is. And, that's kind of the curse of the novice designer. You're always starting from first principles. But expert designers, they aren't doing that. They're reusing solutions they know work.
And that's the core idea, right? That's why today we're doing a deep dive into the absolute foundational text, Chapter 1 of Design Patterns, Elements of Reusable Object-Oriented Software.
hmm This chapter is all about formalizing that expert experience. It's about cataloging those proven solutions.
Our mission today is to really unpack that. We're going to define what a design pattern actually is, how it gets documented, and I think most importantly, the core design principles it helps us all implement.
Let's do it.
Okay, so let's start at the very beginning. What fundamentally is a design pattern?
Well, the idea actually comes from, of all places, architecture, Christopher Alexander. But in our world, in object-oriented design, a pattern really describes two things. First, a problem that just keeps showing up again and again.
Right.
And second, the core of the solution to that problem. And it's expressed in terms of objects and interfaces. And it's a template, really, not a piece of code you just copy and paste.
That's a huge distinction. So it's not a low-level thing like a linked list, but it's also not like a whole application design. It lives in that middle space.
Exactly that. And for something to be a real pattern, the book says it has to have four essential elements.
Okay, let's break those down. What's the first one?
The first is the pattern name. And this is more powerful than it sounds. It gives us a shared vocabulary.
A shorthand.
A shorthand, exactly. We can just say, let's use the strategy pattern here, and the whole team immediately understands a complex design decision without needing a giant diagram.
Okay, so you have the name. What's next?
Next is the problem. This is all about the context. It describes when you should apply the pattern and why. It often describes the symptoms of a bad design that you're trying to fix.
So it tells you what to look for in your own code.
Then, number three is the solution. This is the abstract part. The classes, the objects, their relationships, and what they're all responsible for. It's the blueprint.
And the book says the last one is the most critical. The consequences. Why is that so much more important than just the solution itself?
Because every pattern is a trade-off. There's no free lunch. The consequences section tells you what you gain, but also what you lose.
So the pros and cons.
The pros and the cons. You have to know the cost. Take the observer pattern, for example. The benefit is incredible decoupling, but a consequence. It can be a performance hit.
How so?
Well, you've introduced all this indirection. A single change can trigger a whole cascade of notifications to objects that don't even know about each other. That can be slower than a tightly coupled system.
Got it. So if I'm building, say, a high-frequency trading system, the consequences section might warn me that observer, for all its beauty, might be too slow for my needs.
Precisely. It makes you a responsible designer. You're weighing flexibility against things like performance or memory usage. You're not just building something that works, you're building something that works sustainably.
Okay, let's make this more tangible. The chapter uses the classic Model View Controller, or MVC, as its main example.
Yeah, the Smalltalk 80 triad. It's such a perfect illustration because it's not just one pattern, it's a bunch of them working together to achieve one big goal.
Which is decoupling, right?
Decoupling. You have the model, which is your application data and logic.
Yeah.
You have the view, which is what the user sees on the screen. And the controller handles user input. The whole challenge is making sure the view and model can live independently.
Right, so if the data in the model changes, all the views need to update. But the model shouldn't have to know if it's talking to a pie chart or a spreadsheet. How do they solve that?
They use the observer pattern. It works through what they call a subscribe-notify protocol.
Okay, paint a picture for us.
Imagine a single model object in the middle. Maybe it's holding stock data. It has a list of its observers. And around it, you have three different views. One is a spreadsheet, one's a bar chart, one's a pie chart.
All showing the same data differently.
Exactly. When the stock price in the model changes, it just goes down its list and tells each observer, hey, I've changed. You should update yourself. It doesn't know what they are or what they'll do.
So it's just broadcasting into the void. And the views are the ones responsible for listening and reacting. That's the core of observer.
That is pure decoupling. You can add a brand new type of view tomorrow, and you don't have to change a single line of code in the model.
Okay, but what about the view itself? User interfaces can get really complex, with, panels inside of buttons.
Right, that nesting problem.
How do you treat a single simple button the same way you treat a whole complex window pane?
That problem is solved by the composite pattern. Composite lets you build these tree structures of objects, and this is the key. It lets clients treat individual objects and compositions of objects in the exact same way.
So the code that says draw yourself doesn't care if it's talking to one button or a whole screen full of components.
It doesn't care at all. Uniformity.
And the last piece, the controller. How does this system handle, say, a mouse click or a key press? The view's response might need to change, right?
It might, and that's handled by the strategy pattern. The view itself doesn't contain the logic for how to respond. It delegates that to a separate controller object.
So the controller is the strategy for how to handle input.
Exactly. And if you want to change the view's behavior, you just swap out its controller object for a different one. Maybe you swap in a read-only mode controller or an edit mode controller. The algorithm is encapsulated and can be replaced on the fly.
That's amazing. So you have observer managing change, composite managing structure, and strategy managing behavior, all in one little triad.
It's why MVC is such a foundational concept.
It also makes it really clear that a simple diagram could never capture all of that. The decisions, the trade-offs.
Not a chance. And that's why the book is so rigorous about the documentation standard. You need a consistent template to capture the why.
Right. There's a whole list of sections in the template, but we can probably focus on the ones that really capture the design experience.
Agreed. Beyond the name, I'd say the three most important are the intent, the motivation, and the consequences.
Okay, intent. That's like the elevator pitch.
Yeah, what does this pattern do? What's its purpose? Then motivation is crucial because it tells a story. It gives you a concrete scenario that shows the pain of an inflexible design and then shows how the pattern resolves that pain.
And we already covered consequences, the trade-offs.
Right. And if a so-called pattern doesn't clearly articulate those three things, intent, motivation, and consequences, and it's probably not a true design pattern, it's more of an idiom or just a technique.
It's missing the decision-making context.
Right.
So with 23 patterns in the catalog, you need a way to find the one you need. How do they organize them?
They used a really clever two-axis system. The first axis is purpose.
Purpose being what the pattern does.
Right. And there are three categories. Creational patterns are all about the process of creating objects.
Like a factory.
Yep, like
Yeah.
factory method. Then you have structural patterns, which are about composing classes and objects into larger structures. Think adapter or composite.
Okay, and the third?
Behavioral patterns. These are all about how objects interact and distribute responsibility. Observer and strategy are classic behavioral patterns.
So that's the first axis. What's the second?
The second is scope, and this is all about how the pattern achieves its flexibility. Is it at compile time or runtime?
Ah, yeah.
So you have class patterns, which use inheritance to establish relationships. They're static, they're locked in at compile time,
And then you have object pattern.
which use object composition. These relationships are created at runtime, so they're way more dynamic and flexible. And crucially, most of the patterns in the book fall into this object category.
So that 3x2 grid creational, structural, behavioral versus class and object, it gives you a map of the entire design space.
It's a complete map. It lets you find a solution based on the kind of flexibility you need. If you need to change behavior at runtime, you look in the object patterns column.
That's a powerful way to think.
Yeah.
It leads right into the two core design principles the chapter really hammers home.
It does. The first one is the big one. Program to an interface, not an implementation.
We hear this all the time, but what does it actually mean in practice?
Well, an object's interface is just its public contract, the set of messages it responds to. The implementation is the actual class, the code that does the work.
So your code should depend on the contract, not the concrete details.
Exactly. Your variable types should be abstract classes or interfaces, never concrete classes. Because if you do that, you can use polymorphism and dynamic binding to swap out the actual object at runtime.
And the client code never knows the difference.
It never knows. It's completely decoupled. And that is the foundation of almost all flexibility in object-oriented design.
And that idea feeds directly into the second big principle, which can be a bit controversial: favor object composition over class inheritance.
Yeah, people often see inheritance as like the central pillar of OHO, but it has its dangers.
Why is that?
The book calls inheritance white box reuse. When you inherit from a class, you're often coupled to its implementation details. If the parent class changes, your subclass can break in unexpected ways. It violates encapsulation.
So it's fragile.
It can be very fragile. Composition, on the other hand, is black box reuse. You build functionality by assembling objects that communicate through stable public interfaces.
Which respects encapsulation.
It totally respects encapsulation, and it lets you change relationships dynamically at runtime.
Can you give us that classic window rectangle example?
Sure, so instead of having a window class inherit from a rectangle class to get its shape,
Saying a window is a rectangle.
right. Instead of that, you say a window has a shape object. It holds a reference to an object that implements a shape interface, and it just delegates all the geometry calculations, like calculating its area, to that object.
So the window doesn't do the math itself.
It doesn't. And the beautiful part is, if you want your window to suddenly become a circle, you just swap out the internal rectangle object with the circle object at runtime. The window's behavior changes, but the window class itself doesn't.
That's delegation. And that's the kind of flexibility we're aiming for.
That's it. It's all about designing for change.
Which is really the theme of this whole chapter. Patterns are tools to anticipate and manage change.
They really are. They help you avoid hard coding things. Patterns like abstract factory keep you from naming specific classes when you create objects. Patterns like strategy let you isolate algorithms that you know are going to change.
And they fight against that dreaded tight coupling.
Yep. Things like facade or observer are all about managing dependencies so that a change in one part of the system doesn't cause a ripple effect across the entire thing.
So we have these patterns. Where do we use them? The book talks about toolkits versus frameworks.
Right. A toolkit is just a library of reusable classes. Think of a collections library. You call its code when you need it. It's focused on code reuse.
And a framework.
A framework is a bigger deal. It's a whole reusable architecture for a specific domain, like a web application framework. It focuses on design reuse. The key difference is something called inversion of control.
Inversion of control. Okay, what's that?
With the toolkit, your code is in charge. You call it the library. With a framework, the framework is in charge. It runs the main loop, and it calls your code when it needs to.
So you're plugging your custom logic into a pre-existing skeleton.
You are. And for that skeleton to be useful, it has to be incredibly flexible, which is why frameworks are just packed with design patterns. Patterns are the atoms that frameworks are built from.
This has been a fantastic overview. Let's try to wrap this up with the key takeaways.
I think we've hit the big ones. First, design patterns capture successful expert experience. They're not just made up.
And they're defined by those 4 elements: name, problem, solution, and especially the consequences.
And they push us, they force us to follow the 2 most important principles of flexible design program to an interface.
And favor composition over inheritance.
That's the core of it.
So for you listening to this and wanting to start using these, the book gives some simple advice. Don't try to memorize all 23 at once.
No, please don't. Start by just scanning the intent section of each pattern. Get a feel for what they're trying to do. Or even better, look at the table called aspects that can vary.
That's a good tip. So
Yeah.
you identify what part of your design you need to be flexible, and that table points you to the right pattern.
Exactly. It's a diagnostic tool.
And once you find one that looks promising, what are the steps?
First, read the overview. Check the applicability and consequences. Make sure the trade-offs are right for you. Second, study the structure and collaborations diagrams to see how you'd map it to your own classes. And third, look at the sample code.
Great advice. And I think we should end with the final provocative thought from the chapter.
Go for it.
It's this idea that the program you write, the static class hierarchy on your screen, often looks nothing like the web of communicating objects that actually exists at runtime.
It's so true. The compile time structure is static, but the runtime structure is this dynamic, shifting thing.
And design patterns. They are the tools we use to manage that gap. They're how designers intentionally build systems that are dynamic, flexible, and ultimately truly reusable.